Question number 8 says, calculate the absolute pressure at the bottom of a freshwater lake at a depth of 22.8 meters. Assume the density of the water is 1 times 10 to the third kilograms per cubic meter, and the air above is at a pressure of 101.3 kilopascals. And then B, what force is exerted by the water on the window of an underwater vehicle at this depth if the window is circular and has a diameter of 30.6 centimeters? So let's just assume, for argument's sake, that right here is 22.8 meters. Okay, so there's a column of water, and in this column of water, this water has a certain mass, and the mass is exerting a force that's equal to the mass times the gravity. So the question wants to know the pressure. What's the pressure right there? And the answer is that the pressure is equal to, or the average pressure is equal to the force divided by the area. And so we know that we can break down the force as mass times gravity. So this is mass times gravity divided by the area. And so we have the mass is equal to the density times the volume. And this is supposed to be a Greek rho. Rho times V is equal to the mass. Well, the volume, so we can plug in this for mass. So we say that the average pressure is equal to the density times the volume times gravity divided by area. Well, the volume is, in this case, let's assume that the volume is equal to the area times the height. So imagine it like this. You have a column of water, and let's just say it's a square, or it's a rectangular prism column of water. And so this area at the bottom, which we could kind of draw a line over and draw a line down, this area at the bottom, which we'd call it base times width, and then times the height. So this base times the width is this. It's the area that it's exerting down on. So when we were saying earlier that it was pushing down on the area right here, we were talking that area is the base times the width. And so when we're trying to figure out the volume, we're going to find out that this actually cancels out, because the volume equals the area times the height. So we can go ahead and plug in area times height instead of volume. So we'll say that this equals the density times the area times the height times gravity divided by the area. And now we get that the area cancels itself out. So the area is arbitrary. And we're going to end with a formula for pressure, that the average pressure is equal to the density times the height times gravity, and that's it. And the only thing we got to do now is figure out what the density. So the density is equal to, it says that the density of water is 1 times 10 cubed, so 1,000 kilograms per cubic meter. And then we need to know that the height, that says at a depth of 22.8 meters, and gravity, of course, is 9.8. So our formula is that the average pressure is the density of water times the height and times the gravity. So that equals 223,440. But before we plug that in as our answer, let's go back and read the question. It says, calculate the absolute pressure at the bottom of a freshwater lake at a depth of 22.8 meters. Assume the density of water is 1,000 kilograms per cubic meter, and the air above is at a pressure of 101.3 kilopascals. So the absolute pressure is equal to the pressure of the water plus the pressure of the air. And so this is going to be 223,440 plus the pressure of the air is 101,300 pascals. So this is in pascals. We converted from kilopascals into pascals for the air. We just add those together and we get 324,740 pascals. And so that's our final answer for part A. And then in part B it says, what force is exerted by the water on a window of an underwater vehicle at this depth? So imagine for a second that we have a small little window right here that let's just call our peering glass, and the window was at that same depth of 22.8 meters, and it wants to know what the pressure would be if the diameter of that window was 30.6 centimeters. Or rather, what's the force on that window? So we can actually set an equation for force. So force equals the pressure times the area. So if you remember, our formula for pressure was the force divided by the area, and so all we've done is we've multiplied the area over to the other side to get our equation for force. And we said in part A that our pressure was equal to 324,740 pascals. And so all we need to know is what's the area, and it tells us that the diameter was 30.6 centimeters, and so if we convert that to meters, it's 0.306 meters. But in order for this to be helpful for us, we have to turn it into a radius. So we have to divide it by 2. So the radius is equal to 0.158 meters. And our formula for the area of a circle is that the area equals pi times the radius squared, or pi r squared. And so for the area, I get 0.07842 square meters. And all you have to do is plug in your numbers for your force equation, so the pressure times the area, and it should equal something like 25,468.29 newtons.